So in this question we have a straight line which is drawn joining the points 7, 1 minus p and 2p plus 1 minus 1, and we don't know what p is, it's a constant. And we want to know the complete set of values for p for which the gradient of this line is finite and greater than 0. So the first thing we need to do is find the gradient, so why don't you try and find the gradient of this line? Pause the video and have a go at doing this now. So hopefully you remember that the gradient is the change in y divided by the change in s. This is a delta, and what it means is change in, so change in y divided by change in s. Okay, well, the change is just this value minus this value and this value minus this value, so we get something which looks like this. We can simplify this down to get the gradient is 2p minus 6 over p minus 2. So the next thing we need to think about is this bit of the question which says the gradient of this line is finite and greater than 0. Greater than 0 is fine, we can deal with that. We also need that it's finite, which means that we can't be dividing by a 0 anywhere. Okay, so we need that this 2p minus 6 over p minus 2 is strictly greater than 0. And there are two possibilities in which this could happen. So see if you can work out the two scenarios in which this fraction will be greater than 0. Okay, well the first scenario is that the top is positive and the bottom is positive, so both are strictly greater than 0. And this gives us some values of p. So p is either greater than 3 and it's greater than 2 for this to be true. So now for the second one, we could also have that they're both strictly less than 0, because if this is strictly less than 0 and this is strictly less than 0, then the negatives will cancel out and we'll get something greater than 0. So in this case, we have that p is less than 3 and less than 2. So now it might be a bit confusing because we seem to have 4 inequalities for p, which doesn't really make any sense at the moment. But if we have a look at what this actually means, so let's look at the first one. So we have p is greater than 3 and p is greater than 2. But if p is greater than 2, then it's definitely greater than 3. So we don't really need this first, p greater than 3. So the important one is that p is greater than 2, because this covers everything greater than 3 as well. So similarly for this second one, we have p is less than 3 and p is less than 2. So which one of these do you think we need to really think about? Okay, well, it's p is less than 2, because if p is less than 2, then it's definitely less than 3. So this is a stronger condition than this. Okay, so now we have p greater than 3 and p less than 2. So our answer is F.